Good day, students. Today, I want to solve problem under homogeneous differential equation. When you have a equation like this, we notice that the equation expressed at the right hand side, cannot be expressed as x factor and y factor. Because of that, you cannot apply uh, separating of variables. Is that okay? There will not be application of separation of variable in this case at the initial stage. But we are going to get to that point by separating the variables when we substitute y equals to vx in the equation. And also know that when you are solving a problem like this by substitution, anywhere you see y, you introduce vx. V is a function of x. You now differentiate y with respect to x using product rule. When you get dy dx under this first equation, you keep it somewhere. I already have dy over dx. When you now substitute your y into the equation given, whatever you get as your expression, you now equate the differentiation you have at this point, the first equation, equate it with the second one because both of them are being expressed in terms of the y dx. Okay, now let's start. Now, from this first point, you're having the first equation y equals vx. You want to apply product rule. Apply product rule. When you apply product rule, don't forget that when you are differentiating x, let me say you're having y equals to x, okay? dy dx equals, there's one here, there's one here. Now I have 1 times 1. This one comes to the back. X raised by 1 minus 1 plus 1 times 1. X raised by 0. Anything raised by 0 is 1. 1 times 1, 1 times x raised by 0 is 1. 1 times 1, 1. See? What the formula apply here is this. When you're having y equals to ax raised power n, dy over dx equals a dot n x n minus 1. That was applied to get the differentiation of x. Now let's apply product rule here. dy over dx equals, you keep the first letter and differentiate the second one, and now keep the second one and differentiate the first one. Okay, now I have v dx, differentiation of x is 1. Okay, plus not write x now and differentiate v with respect to x, dv over dx, which is v times 1, that's v, plus x dv over dx. Now, you have gotten your dy dx to be v plus x dv dx. X dv dx. Now, you now go back to the equation given. You now have, and don't forget that under homogeneous differential equation, it must always come to your mind that you must substitute y equal to vx. That's the condition under homogeneous differential equation. Y equals to vx is substitute in the equation given. You now have dy over dx equals x plus, wait, let me write it as substitute y equals to vx in the dy over dx equals x plus 3y over 2x. You now have it to be dy over dx equals x plus, instead of writing y, now say 3vx over 2x. Okay, now let's factorize what's common out. X is common, x into 1 plus 3v over 2x. X cancel x. Dy over dx equals 1 plus 3v over 2. Can you see now that you're having two expressions for dy dx? When we differentiate what you are substituting, dy dx, you're having v plus x plus dv, x v plus x dv over dx, and also you're having dy dx equals 1 plus 3v over 2. Now let's just call this one equation 1 so that you don't get confused. Equation 1, this one equation 2. Now equate, because they are both dy dx, express it as dy dx. Now say equate equation 1 and 2. Create equation 1 and 2. Now the expression will now be in this form. The first one is v plus x dv over dx equals the second one 1 plus 3v over 2. 1 plus 3v over 2. Okay, take v to the other side. Now have x dv over dx equals 1 plus 3v over 2 minus v over 1. Now you have x dv over dx equals, LCM is 2. 2 goes into 1 times 1 plus 3v, that's 1 plus 3v. 1 goes into 2, 2 times v, that's minus 2v. Now x dv over dx equals 1 plus v over 2. Okay, now see, we have now expressed it in terms of v and x. At this point, we can now apply separation of variables. Apply separation of variable in this case, in which integration will take place. Separation of variables, which integration will take place. Okay, now let's cross multiply. I'm going to see how integration will take place. Now I have 2 cross multiply. When you do that, you're having 2x dv, 2x dv, 2x dv equals 1 plus v dx. Now you want to do it in such a way that the v, the v with 1 plus v will be one side, those with x will be in the other side. What I will do now is divide both side by 1 plus v, 1 plus v. 2 is a constant, cancel out. Now I have 2 x dv over 1 plus v equals to dx. Now I want to take x to the other side, divide both sides, multiply by 1 over v, sorry, 1 over x, 1 over x, so that's 1 over x times the expression here. You do the same thing to the other side, that's 1 over x. X will cancel this x out. You are left with 2 over 1 plus v equals 1 over x dx. Okay, now you now integrate both sides. Integrate both sides. Integrate both sides. When you integrate both sides, you now put your integration sign. Integral of 2 over 1 plus v dv. Don't forget we're having dv here, please. We're having dv. Okay, consider dv. 2 over 1 plus v dv equals integral of 1 over x dx. Okay, you can see that we have applied separation of variables when you replace your v equals to y equals to vx. Okay, now you now have expression like this. Now you now have 2. What you have here is 2 ln 1 plus v, because when you have this expression like this, integral of under integration, integral of 1 over 1 plus v dv, that's ln 1 plus v, will give you this. It will give you 1. That's where you have 2 ln 1 plus v, okay, equals to ln x ln x plus c ln x plus c. And let's make our c, since everything is in terms of ln, let's make our c to be ln a. Let's assume it to be ln a. Okay, let's now say our c should be ln a. Let's try it like that, where c equals ln a. Okay, now we now replace c with ln a. Now two ln 1 plus v. Okay, don't forget ln x will give you 1. That's why I said ln x. 1 over x is ln x. Okay, ln x will give you 1. This expression, when you have 1 over x, is it as just write ln x. 1 over 1 plus v is ln v. Okay, but this 2 is a constant, it comes out. But anywhere you see 1 over x is ln x, plus, when you remove the integral sign, you have to put plus constant. We have to put plus constant at the right hand side because that's where the constants needs to be. Okay, but we now assume where c equals ln a. Anywhere you see now c, you put ln a there, because we want everything to be in terms of ln. That's our constant. Now 2 ln 1 plus v equals ln x, plus we have made our c to be ln a. Okay, now let's 2 comes to the front. Ln plus ln 1 plus v, ln 1 plus v squared. Okay, these 2 comes to the front as the power, equals under addition, multiplication will now be ln ax ln, as addition multiplication, ax under indices. Now this ln cancel this ln, you are left with 1 plus v squared equals to ax. Now don't forget that you're having y to be equals to your substitution, y equals to vx. I told you that under homogeneous differential equation, you must substitute v equals to y equals to vx in this equation, and at the same time you want to replace v with v equals to y over x. When you divide both sides by x, you have v equals to y over x. Substitute, let's call this one equation 3. Substitute y v equals y over x in equation 3. When you get that, you have anywhere v, you replace it y over x. You're having 1 plus y over x, okay, squared equals to ax. Don't forget this over 1. What's the LCM? LCM is x. 1 goes in x times 1, x plus x in x1, 1 times y, that's y. Everything squared equals to ax. Okay? Now from here, don't forget that this the numerator can separate the squared, now be x plus y squared over x squared. See the same thing. You squared both the numerator and denominator separately equals to ax. Now let's cross multiply. Now where x plus y squared equals to ax times x squared. Now you're having x plus y squared equals x times x squared, that's ax cubed. Ax times ax times x squared, that's ax cubed. Okay, you can see this is the final expression, and don't forget that they're having the same power. Okay, you can see the power x raised power 1, 3y raised power 1 to x power 1. These are the condition you have to be looking at under homogeneous differential equation, and you have to make it to be able to be solved by applying separation of variables, or you can apply that when you substitute y equals to vx into the equation given. You now differentiate y with respect to x using product rule. Now substitute this expression y equals to vx into this equation. By the time you solve it, the end of the equation is x plus y squared equals to ax cubed. This is how to solve the problem under homogeneous differential equation. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.